Welcome to Nano Summit 2025. My name is Vladimir Bulović. I have a privilege to work at MIT.nano. And I'm just absolutely thrilled to see a room filled with students, faculty, researchers, our corporate partners, other entrepreneurs. I mean, this is an incredible opportunity for us to tell you of the multitudes of ways MIT.nano is changing the way we think about the future and what it's going to deliver. Indeed, your presence shows the uniqueness of the community that MIT.nano is built to serve. And hence, I'm absolutely overjoyed to show you throughout the day various ways MIT.nano indeed intends to change the world through your work and the opportunities that you'll bring for everyone. 2025 marks the 7th year of MIT.nano. When MIT first imagined building MIT.nano, the goal was not just to create new labs or acquire the best tools and instruments. The vision was much bigger. It was to create a catalyst for discovery, a place where ideas and disciplines meet, where conversations happen across the fields, and where discoveries at the smallest scale can grow into solutions with global impact. When MIT.nano opened in 2018, it represented a bold investment in the future of science and engineering at MIT. Since then, the facility has matured into a thriving community of users. At this point, we have over 1,500 annual users at MIT.nano, drawn from over 300 different PI labs across the campus and beyond. You know, what anchors us is not just the 200 plus tools, but the people who use them, teach with them, and push the instruments to reveal the next great breakthroughs. I often say MIT's two most important deliveries to the world are our knowledge and our people. At MIT.nano, both those circulate freely. Students, faculty, and researchers exchange insights, test ideas, and build on each other's work in hopes of leaving this place and the world better than when they arrived. And last 7 years tell us that they keep continually succeeding. At MIT.nano, curiosity meets the capability. Experiments generate knowledge, expand understanding, and provide the foundation for innovations that have an impact across all different disciplines. We have over 50 different departments, labs, and centers that utilize MIT.nano. We were hoping for that when we started. The fact that we can now count it and actually recognize the delivery of it, indeed, is overwhelming. Roughly 21% of MIT faculty touch MIT.nano to get their work done. In 7 years of existence, that's quite a growth. Annually, we keep adding about 20% of the user base. And so, at some point, a couple of years from now, we'll be talking about 2,000 users, and not just from MIT. About 20% of them come from the external world that needs our tools to make their discoveries happen. We are a community centered at MIT, but the one that is here to benefit the region and the nation. Within MIT.nano, there are facilities that open different windows into innovation. Fab.nano gives researchers the ability to fabricate at the smallest scale, transforming bold concepts into tangible structures. Characterization.nano lets us look at materials with extraordinary precision, revealing properties that guide new breakthroughs. And the Immersion Lab offers an entirely different perspective, one where technology and human experience intersect, expanding how discoveries can be applied in the world. Our programs, well, we have many of them. Here are just 3 to mention. MIT.nano has created pathways that carry knowledge and creativity beyond the lab. For example, in Star.nano, we support high-tech entrepreneurs as they take the first step toward building companies that can scale. And if you're here yesterday afternoon, we held our very first Pitch.nano competition where a dozen startups dazzled those who participated, lifting up actually the exposition of what is it to present new science and technology. Studio.nano fosters new ways of communicating ideas, helping researchers connect with wider audiences. Our collaboration with Tecnológico de Monterrey builds bridges across borders, strengthening global networks of talent and innovation. And so each of these programs really extends our reach. We have a well-functioning facility. We have an opportunity to, within that facility, to bring tremendous number of brilliant people. Next thing we need to do is, beyond the tools, offer them ways to engage through these programs. The same spirit of bold collaboration and curiosity shaped the sessions you're going to hear today. We designed the program you're going to experience today to reflect some of MIT's strategic priorities as outlined by our president of MIT, Sally Kornbluth. The challenges the Institute has identified as most urgent for humanity are the areas where nanoscience has the powerful role to play. After all, the world is built from atoms up, and we know how to make every one of them exactly where it needs to be. You'll hear sessions on health and life sciences to start us off. Nano provides the tools, sensors, interfaces, and delivery systems to transform how we diagnose, treat, and even prevent new types of diseases. Manufacturing, well, breakthroughs only matter if we can scale them, so the session will explore how breakthroughs in nano can translate into real-world products and reliable systems that can change entire industries. On climate and sustainability, well, from clean energy to carbon capture to resilient infrastructure, nanoscale materials and devices are central to our response to the climate crisis. We then follow these three sessions with student talks and our researcher talks. Talks, so-called PICO talks from inside the lab, led by the people who guide the students through the lab, Anna Osherov and York Shulvin. In celebration of MIT's culture of discovery and education, this session highlights some early stage ideas and researchers whose perspectives are essential to shaping that future. We will close this afternoon with a session led by President Emeritus Rafael Reif, who will tell us about visionaries of nanoscience and nanotechnology that got us to today. These are people whose creativity, leadership, and persistence have built the foundation on which we all stand on today. Recognizing them is a reminder that progress depends not just on tools or facilities, but on human imagination and willingness to pursue bold ideas. As a matter of fact, beyond the session of celebrating the luminaries of time past, we are going to name a space in MIT.nano after one of those luminaries. Please make sure you attend the session and you'll find out a lot more. And then we'll celebrate at MIT.nano. So, as you move through the day, I invite you to think big and stay curious. And any questions that make you want to ask speakers, please make sure you ask them. Share a problem you can't yet solve and see who in the room lights up at the same thought. Some of the most important discoveries emerge when someone with one set of expertise brings a different perspective to another. That human friction leads to innovation. Let's make sure today we have plenty of it as we challenge each other and inspire each other with new ways of thinking. MIT.nano is proof that when people from different disciplines share tools, spaces, and ideas, they discover new pathways forward. We are a facility where talent and knowledge meet opportunity, where a sketch on a whiteboard can become a measurement, a prototype, and eventually a solution that impacts all of us. So thank you for being here today, for contributing your ideas, and for helping us imagine and build the future together. I now have a distinct honor and a privilege. One, to open the 2025 Nano Summit, and two, to welcome on the stage our MIT President and remarkable leader, Sally Kornbluth.
Well, thanks so much, Vladimir, for the introduction. and for your outstanding leadership of making MIT Nano such a vital part of the Institute landscape. I mean, the physical landscape, of course, 200,000 square feet that allows for impressive talent, but also your huge contributions to the landscape here of ideas and exploration that really helps make MIT MIT. So MIT Nano obviously started before my time at MIT, but I know that it was designed to be a fantastic toolbox for this community, or as Vladimir describes it, a gathering space that doesn't do all, but enables all. Now, for my part, I can't tell you how excited I am that MIT Nano is essential to making progress to high priority areas where I believe that MIT has a responsibility to lead. Areas where, if we harness our collective efforts, we can make a serious positive impact. First, it's pretty fantastic, just as we're renewing our focus on helping the nation regain strength in manufacturing, MIT Nano is helping us expand our industry partnerships, explore pioneering approaches, and importantly, train our students in everything from fabrication, computational modeling, 3D printing, and how to work successfully as part of a team. And it's especially exciting that MIT Nano is imagining new fields that will shape the future of manufacturing and helping young companies advance the most promising technologies and then develop them to scale. Now, with MIT Heals, launched last year, I'm focused on bringing MIT experts and leaders in biotech, pharma, and hospitals together, making sure that they have the resources and the infrastructure they need to accelerate healthcare for patients around the world. And they collaborate on new knowledge, new tools, new cures, and MIT Nano allows them a place to work on diagnostics and therapeutics that range from lipid nanoparticles to wearable sensors to a pill that releases bacteria into the GI tract to treat and diagnose disease. And from human health to the health of the planet. I'm sure you know that MIT has begun an ambitious push to accelerate climate solutions, and despite strong headwinds and reductions in federal support, we are continuing that work. The intersection of climate and nanotechnology is sparking all kinds of ideas, like new and improved materials that produce fewer emissions and remove pollutants from the air, and nanopores that monitor environmental conditions in the air, water and soil, and new methods of capturing carbon dioxide, and then turning that into useful products. And even plants that can turn their own stored chemical energy into visible light for human use. This almost sounds like science fiction, but it's incredible. And all of this is just scratching the surface of the nano-enabled research in manufacturing, in climate, in life sciences, and health, happening all across MIT, along with innovation in other key areas from AI to quantum. And you're going to be hearing a lot more about quantum at MIT in the coming year. MIT Nano has truly set itself apart in the Institute's signature way, with an emphasis on cross-disciplinary collaboration and open access, welcoming anyone who requires nano tools to make things and then scale up the things they make. And, you know, as Vlad showed, the number of users is just continuing to increase. And here's something I find truly heartening for all of us who value science, both fundamental and applied. Even with the advanced nano tools we now have literally at our fingertips, we're still acting on the same human instinct, the same curiosity we have, the drive to make things, to understand how they work, and how to make them work for us in new and exciting ways. Now, I know you want to hear from all of the amazing speakers, but before I go, let me tell you one more thing about MIT Nano that's music to my ears, and Vladimir mentioned it. This is really a fantastic training ground for our students. Now, 40% or so of students, even more actually, major in computer science. But I've been told by a reliable authority that when students have the opportunity to work at nanoscale early in their MIT careers, a significant number actually consider majoring in something else. Now, I'm not, I am not dissing course 6, believe me. But it's no surprise that MIT students who spend so much time in their lives interacting with digital systems often find making things, using nano tools deeply, deeply satisfying. It's a reason that so many MIT students are drawn here in the first place, a love of making things that matter, and an impulse to seek out the company of other people who share that passion. Now, today you're going to hear from all kinds of makers, faculty and researchers, students and postdocs, entrepreneurs and industry leaders, about the transformative impact of nanoscience and nanotechnology, and how working with the very small can help us do big things for the world together. Now, finally, I'll say one thing. So I have two dogs, and I have this little dog called Pico, and I was very appreciative to get a 10 to the minus 12 T-shirt because but had I known I was coming to MIT, I would have named him Nano. So anyway, I want to thank you for being here, and I hope you all enjoy the day.